Okay, now what has this got to do with the problem we started with originally? The problem is to explain this blue series. So our problem is, how from this am I going to get the terms of this blue series? So given f of t, 2 pi is a period, find the an and the bn. Okay, let's focus on the an. The bn is the same. Once you know how to do one, you know how to do the other. So here's the idea. Again, goes back to something you learned at the very beginning of 1802, but I don't think it took. But maybe some of you will recognize it. So what I'm going to do is write, here's the term we're looking for. Here, this one. Okay? And there are others. They're long. It's an infinite series. It goes on forever. And now, to make the argument, I've got to put in one more term here. So I'm going to put in ak cosine kt. I don't mean to imply that that's comes, or k could be more than n, in which case I should have written it here. I could have also have used equally well sine kt, bk sine kt here, and I could have put it there. You know, this is just some other term. This is the an, this is the one we want, and this is some other term. Okay? All right, now what you do is, to get the an, what you do is you multiply everything through by, you focus on the one you want, and you, so it's dot, 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 and you multiply by cosine nt. So it's ak cosine kt times cosine nt. Of course, that gets multiplied too. But the one we want also gets multiplied. an, and it becomes, when I multiply by cosine nt, cosine squared nt. And now, I hope you can see what's going to happen. Now what I'm going to do, oops, I didn't multiply the f of t. Sorry. It's the oldest trick in the book. I now integrate everything from minus to save, so I don't endlessly recopy. I'll integrate by putting it up in yellow chalk, and you are left to your own devices. This is definitely a colored pen type, of course. Okay? So, you want to integrate from minus pi to pi? Good, just integrate everything. Everything on the right-hand side also from minus pi to pi. Plus these other guys, just to indicate I haven't, you know, they're out there too. And now what happens? What's this? 0. Every term is 0 because of the orthogonality relations. They're all of the form a constant times cosine nt times something different from cosine nt. Sine kt, cosine kt, or even that constant term. All of the other terms are 0, and the only one which survives is this one. And what's its value? The integral from minus pi to pi of cosine squared, I put that up somewhere. It's right here. Down there, it is pi. So this term turns into an pi. An dragged along, but this, the integral of the square of the cosine turns out to be pi. And so the end result is that we get a formula for an. What is an? An is, well, an times pi. All these terms are 0, and nothing is left but this left-hand side. And therefore, an times pi is the integral from negative pi to pi of f of t times cosine nt dt. But that's an times pi. Therefore, if I want just an, I have to divide it by pi. And that's the formula for the coefficient an. The argument's exactly the same if you want bn, but I'll write it down for the sake of completeness, as they say, and to give you a chance to digest what I've done. 30 seconds to digest it. Sine nt dt. And that's because the argument's the same, and the integral of sine squared nt is also pi. So there's no difference there. Now, there's only one little caution. I have to be a little careful. This is n1, 2, and so on. And this is also n1, 2. And unfortunately, the constant term is a slight exception. We better look at that specifically, because if you forget it, you can get into gross errors. How about the constant term? Suppose I repeat the argument for that in miniature. There's a constant term plus other stuff. A typical other stuff. An cosine, let's say. How am I going to get that constant term? Well, if you think of this as sort of like a constant times, the reason it's a constant is because it's being multiplied by cosine 0t. Well, cosine 0t is 1, so that suggests I should multiply by 1. In other words, what I should do is simply integrate this from negative pi to pi, f of t dt. What's the answer? Well, this integrated from minus pi to pi is how much? Is c0 times 2 pi, right? And the other terms all give me 0. Every other term is 0, because if you integrate cosine nt or sine nt over a complete period, you always get 0. There's as much area above the axis or below, or you can look at two special cases, Anyway, you always get 0. The same thing with the sine here. So the answer is that C0 is a little special. It's not, you don't just put n equals 0 here, because then you would lose a factor of 2. So C0 should be 1 over 2 pi times this integral. Now, there are two kinds of people in the world, the ones who learn two separate formulas and the ones who just learn two separate notations. So what most people do is they say, look, I want this to be always the formula for A0. That means even when n is 0, I want this to be the formula. Well, then you're not going to get the right leading term. You're not going to get C, instead of getting C0, you're going to get twice it, and therefore the formula is, the Fourier series, therefore, isn't written this way. It's written, if you want an A0 there, calculated by this formula, then you've got to write not C0, but A0 over 2. I think you'll be happiest. If I have to give you advice, I think you will be happiest remembering a single formula for the ANs and BNs, in which case you have to remember that the constant leading term is A0 over 2 if you insist on using that formula. Otherwise, you have to learn a special formula for the leading coefficient, namely 1 over 2 pi instead of 1 over pi.